The most significant obstacle in this specific methodology is the reality that we cannot observe the gravitational waves or the residual radiation resulting from the expansion itself. So, while our entire understanding hinges on theoretical principles, scientific theories always have ample scope to be refuted. Yes, we're quite confident about the Big Bang as a concept and its monumental role in shaping our universe, but there are some aspects of its aftermath that we have misunderstood. And, as surprising as it is, theories about our universe are largely built on data susceptible to human mistakes. At the same time, some of our data is also highly definitive regarding the Big Bang. Let's just say that, at this juncture, it's challenging to disprove the theory entirely. In the past decade or so, our sole opportunity to study the Big Bang was through the Hubble Space Telescope, and now, of course, all hopes are pinned on the remarkable accuracy of the James Webb Space Telescope. Before we had access to these advanced technological tools, one of the major controversies in astronomical research was the expansion of the universe. If you pick up some science textbooks from the early 90s or so, you'd read about how the universe is widening. In other words, the universe is expanding, and that's the scientific fact we've clung to. However, the real issue here is that perhaps we don't fully grasp what the expansion of the universe involves. More importantly, we need to question if the universe is actually expanding because, spoiler alert, the James Webb Space Telescope suggests otherwise. Surprisingly, the universe has ceased expanding. And hey, while the world remains intact, you might want to enhance your internet experience. Secure and reliable, because we certainly have. This is why we're excited to unveil our own solution for safe browsing and accessing exclusive content. Today's video is sponsored by the leader in secure and accessible internet, Atlas VPN. With over 6 million users globally, Atlas is transforming the game for everyone. All right, this service won't be available in space, but Atlas would make your internet experience extremely secure and fast. Can't watch shows that are restricted in your region? Connect to Atlas and voila, you're in. You don't need to be a tech or computer expert to use this service. It works effortlessly for everyone, and it's just $1.83 per month plus 3 extra months. So why choose Atlas? Atlas protects against malware attacks, keeps your searches private, unlocks content from around the world, and offers the best deals available. You can get all of this for all your devices with a single subscription. Grab the great deal now because Atlas VPN Premium is just $1.83 per month plus 3 additional months, and with a 30-day money-back guarantee. Safeguard your privacy and enjoy numerous benefits of Atlas VPN for an incredibly low price. You can access this deal by clicking the link in the video description below. Act quickly as it's a limited time offer. So, while we thank Atlas VPN for sponsoring this video, click the link in the description to seize the limited time offer. Your internet experience just improved significantly. And now, before delving into the implications of this groundbreaking shift in our universe's trajectory, let's discuss our understanding of this intriguing phenomenon in the first place. The most prevalent knowledge associated with the Big Bang characterizes it as an explosion, and, well, fiction and popular media have provided solid imagery for this process as well. Any media depiction would show the universe's inception as a blast hurling immense energy and matter in every direction. Scientifically speaking, that sort of visualization isn't accurate. Despite the widespread use of terms like explosion and inflation, the birth of the universe wasn't exactly an explosion. Scientists want us to correct our understanding. According to NASA, the universe did not expand into space, as space did not exist before the universe. Instead, it is better to consider the Big Bang as the simultaneous emergence of space everywhere in the universe. Our comprehension of the phenomenon also reveals that our universe has undergone a prolonged cosmic phase, only interrupted by reionization in space. Prior to that particular chemical event, our universe was completely dark. The "let there be light" moment of the universe only occurred 400 million years after the Big Bang. Yes, that's right. You see, the grand explosion only established the fundamental components of all living beings and heavy objects in the universe. For 400 million years, the universe was enveloped in darkness because, simply put, there were no stars or galaxies. When this was corrected, as clumps of gas formed into stars and galaxies, only then did the universe emerge from its cosmic dark ages. So here's a bit of trivia for you. When do you think our solar system was formed? If the universe was just darkness and eeriness for 400 million years, well, our solar system came into existence 9 billion years after the Big Bang. So, sorry sci-fi movies, there's a significant gap between the so-called explosion and scientific theory. And, of course, this changes everything. As it stands, our universe remains as a singular inception point. It hasn't moved or expanded since the Big Bang. What actually occurs is that space has been stretching continuously, carrying matter with its trajectory. To put it plainly, the universe isn't expanding the way we visualize it or even comprehend it. It is actually the active stretching of space that precedes the expansion of the universe. We understand it's somewhat complex to grasp this, but it's also crucial to understand the implications of what we're about to reveal. For the purpose of this video, we continue to use the term expansion of the universe to denote the active movement of our space, mainly because even scientists are comfortable using this exact framing to describe the recent discovery made by the James Webb Space Telescope. The fact that the universe has ceased expanding is both alarming and inconsistent with our previous theoretical understanding of this puzzling phenomenon. So what should we make of it? Let's dive into that. To grasp the implications, we need to revisit our current studies of the universe. When the universe was born, aka during the Big Bang, it was smaller than a single atom. Since then, the universe has been stretching outward continuously. Initially, it expanded outward at unimaginable speeds, but as the universe aged, it continued to expand and stretch further. This was the moment that everyone thought would continue indefinitely. After all, if the Big Bang was a beginning of sorts, we should anticipate a corresponding end. Our theoretical understanding thus suggests that our universe is on a singular trajectory of expansion, without any realistic chance of slowing down. In other words, we were confident in the ever-expanding nature of the universe, and that concept would have allowed us to predict how and when the world would end. The James Webb Space Telescope disrupts our preconceived notions about the universe's expansion. First and foremost, the data from the JWST indicates that the universe's expansion has halted. The latest images from the James Webb Space Telescope reveal that the growth of the universe has markedly slowed. In fact, it appears the universe might not be expanding at all. How did this finding emerge? With the recent images, researchers have observed that light waves seem to be bending as they traverse through space and time. This bending of light suggests that it is the fabric of space that has ceased to expand. The new visuals unveil details beyond what the Hubble Space Telescope could capture. Our earlier understanding was based on Hubble results and didn't uncover the universe's most critical characteristics. The new images have shown that the universe is fundamentally curved. This incredible discovery reveals that the universe is a sphere and everything we know, including space and time, is enclosed within this sphere. Additionally, another major breakthrough is the light captured by the new telescope. The more we analyze the images, the more we find evidence that the Big Bang theory is both correct and outdated. It is correct because the universe originated from a single point and has been expanding ever since, but it is outdated because JWST's new data largely disproves the idea of continued expansion. If we scrutinize the data, we see that the universe, or the spherical point, has stopped expanding. This characteristic suggests a probable end scenario for the universe. As mentioned, the universe began with a Big Bang, but we have not considered the precise nature of its end. Scientists have explored potential ways the universe might end, and spoiler alert, it will likely conclude in the same manner it began. The expansion has ceased, and the next phase will be a slowdown in the stretching of space. The new data also points to a potential end scenario, the Big Crunch. We realize it's a lot to digest, but JWST is enabling scientists to observe the universe's mechanisms more closely. This means we now have insight into the universe's trajectory. Instead of accelerating expansion, the universe has stopped expanding. Therefore, over time, this curvature or sphere encompassing our universe will gradually collapse. This collapse signifies the end of the universe as we understand it. The James Webb Space Telescope is a remarkable tool that is transforming our comprehension of the universe. The latest images from the telescope show light bending at the edges, indicating that our universe has halted its expansion. It also suggests that we are closer to our ultimate end than previously thought. Whether this will occur in the next few centuries or thousands of years is uncertain, But for now, our understanding of the universe has reached a perplexing stage, which is quite alarming. The insights from the James Webb Space Telescope, JWST, have disrupted our grasp of the universe, particularly concerning its expansion and final fate. For decades, the prevailing view was that the universe, which began with the Big Bang nearly 13.8 billion years ago, has been continuously expanding. This expansion, believed to be a result of an explosive origin where space itself rapidly stretched and carried matter, was thought to be a constant and ongoing process. However, the latest observations from JWST challenge this notion. The telescope's data indicates that the expansion of the universe has not only slowed but may have ceased altogether. This revelation points to a potential end scenario, where the universe could experience a big crunch, where the expansion halts and leads to a collapse back into a singular point. This new understanding offers profound implications for our knowledge of cosmic evolution and the ultimate fate of our universe.